Hello everyone. Welcome to my talk, Runtime Security for vCluster using Falco. And nice talk, Ram, and very interesting stuff about the security things. I'll take 2 minutes extra apart from my talk because there's something I want to follow up on what Ram just mentioned, because something that I and some of my friends have been working on. So yeah, my name is Saiyam Pathak, and I'm currently working as Principal Developer Advocate at Loft Labs, and I'm founder of Kubesimplify and BuildSafe. Tell you about Kubesimplify. It's basically a community, a YouTube channel, a blog, a website, Discord, all that stuff to simplify cloud native. We have workshops, courses like WebAssembly, OpenTofu, all the latest tech you'll find there. And BuildSafe actually helps you build those zero CVE based images. So Ram showed you the demo for Chain Guard. So BuildSafe is an open source CLI tool that we built, and it lets you build zero CVE based images, and out of the box gives you the high quality SBOMs, and also it helps you achieve the SLSA, different SLSA levels. So yeah, if anybody is interested in talking about BuildSafe, we can chat about after the call with demos and all that stuff. And yeah, you can connect with me at the Saiyam Pathak on different social platforms. Okay, what is this? House. Not my house. This is an AI generated image. Come on, you should be able to guess that, right? So these are just the houses. So what we'll try to do is we'll try to understand this concept, and then later during the talk, it will be kind of helpful to relate why I'm talking about this. So yeah, let's say you have to buy a house. Buying a house is expensive, right? These days, everything is like super expensive. So, but apart from the cost, there comes like you have extra overhead maintenance. You have to maintain the garden, you have to maintain the parking, you have to maintain, a lot of things. Instead, you can go for the apartments. Although apartments are also expensive, but they're relatively less expensive, especially in Gurgaon, right? But relatively less expensive than the houses. So, and here, one more thing, apart from the cost reduction, what is there are some shared things, shared facilities that you can enjoy, and you don't manage them. There is a maintenance office, and then they maintain all the stuff for you. So you can reuse the elevators, you can reuse the children play area, you can reuse a lot of things. But you still are the owner of the house. Like, you still have the lock and key of your choice. You still have the paint of your choice. You still have the decoration of your choice. It's not that anybody can enter into anybody's place. They are still isolated from each other. But it's like, you get cheaper costs, and you get a lot of shared resources that from an apartment. Now, keeping this in mind, we'll kind of move on. So now we are at a stage where KubeCon is happening in India. Kubernetes has turned 10 years old. It's an old technology now. It's not new anymore. People have been adopting Kubernetes like anything. So earlier, 5 years back or 6 years back, the main challenges were the adoption. People were finding it hard to adopt Kubernetes. Now we have crossed that phase. We are into a phase where enterprises, startups, everyone just creates a Kubernetes clusters on some managed cloud provider, because there have been cloud providers that have emerged, and they provide relatively very easy managed offering. Previously, it was like self-managed Kubernetes clusters were a thing, and people used to create the Kubernetes cluster themselves, manage it themselves, and now things have evolved. Everybody is kind of using their own clusters. But with that, there are new challenges. Like with every evolution, there are new challenges. With DevOps, there are a lot of security stuff that opened up at each stage of the cycle. There are security challenges. Similar to that, when you create the clusters, too many clusters create more challenges. So right now, what the enterprises, like when I talk to the enterprises, what stuff they are doing is they are creating cluster per team because it's simple. You just go click create Kubernetes cluster, select the number of nodes that you need, select the size, and boom, you get a kubeconfig file, give it to them, and let them do whatever they want to do. But what happens with this is, with each Kubernetes cluster, there are a lot of costs associated to that. There are, because Kubernetes itself doesn't, it's a beast ecosystem. It has its own set of resources, like it has its own control plane, API server, controller manager, scheduler. It has its own components to run. And when you say you have 10 Kubernetes clusters, so you'll be having 10 control planes each for each cluster, and then so on and so forth. And you can imagine for 1,000 clusters. Also, when you give someone a Kubernetes cluster, it's just a plain Kubernetes cluster. There's nothing on it. You have to install all the tooling that is required for your application to actually run. So you will deploy your application, then you would want to monitor it. You would want to do GitOps with it. So you will install external toolings for that. And each team wants to do it. So each team will have all the tooling. So this is just one enterprise creating 1,000 clusters, installing 1,000 instances of Argo CD, installing 1,000 instances of Cert Manager, because cross cluster they won't be able to use that, and there are very tricky ways to use that. But yeah, overall they won't be able to do, and there are control plane costs, and every cluster has to be maintained separately. So these are some of the challenges, and these are the control plane costs and the platform costs. So companies are doing this. And as per Gartner, the forecast is that it's going to reach $679 billion in 2024, which is a 20.4 increase, percent increase in 2023. So which is huge, which is massive. And as per the CNCF survey, one of the things that has come up is 70% of the organization, 70% is a big number, 70% of the organization identified over provisioning of the Kubernetes clusters as leading cause of spend. I mean, it's okay, it's common, and it's okay. As developers, you don't know, right, how many resources you need. Even if you type anything in your resource request and stuff, that's just a guess, because you don't know what stuff will be happening. There are tools right now that has evolved over time that helps you right size your cluster, right size your workloads, which are there. But overall, still 70% are doing it the kind of way where they are over provisioning and costs are coming in. And when costs come in, suddenly there is a message from the top leadership team that our costs are surging, do something, and then people start doing it. Same is with security. Like one day there is a vulnerability, you close your laptop on Friday, like Ram said, and Saturday you are working fixing those issues. So it's all depends on suddenly when it happens to you, you will kind of go and see. But now I think with all the maturity things, and due to the meetups like this, it's important to understand where we are, and we have that basic Kubernetes overview. We know how Kubernetes work, how the clusters work. Now we should care about security. Now we should care about cost. Now we should care about how we can right size our workloads, how we can reuse some of the components of the platform stack, reduce the number of clusters that we are running in an enterprise. This is where the concept of multi-tenancy comes in. So multi-tenancy in an ideal situation should guarantee a few things, like it should give you an isolation, because that's what you still would need. It should be less complex, and it should save costs, and it should do the workload isolation. It should be done automatically, and fair use of resources. So in Kubernetes, there is this concept of namespaces. So you all know about namespaces. You can create namespaces, multi-tenancy done, and it's over, right? So let's see what we can do to actually achieve multi-tenancy. So for workload isolation, we have the concept of namespace. Namespace gives you some level of isolation, and you can do a kubectl create namespace demo. It will create a isolated namespace for you, and you can then deploy your resources over there. You can also attach labels to it. You can also enforce the pod security admissions stuff to it. You can define network policy. Now, network policy is a concept for defining what traffic should flow from one pod to another pod, one namespace to another pod, what traffic to restrict. Very important thing to do, and I hope everybody is doing it. So what network policy does is you can define, like here you can see egress to what all is allowed, and to different ports and stuff like that. So let's say you want to create a multi-tenant kind of environment. So this is on a bare minimum that you would want to do. You would want your namespace to at least be able to communicate with the API server. Yeah, I was not able to figure out the CIDR for API, just so you have to additionally like find the command and then do it. You have to allow some ports for routing, and then some CIDR blocks, and maybe you want your namespace to also be able to communicate with some other namespaces, but not all namespaces. So you have to write all this complex stuff. Fair use of resources in a namespace. You can also define a lot of things like how many pods a particular namespace can, a person in a particular namespace can create, or a service account in a particular cluster can create, and then how many services, how many config maps, what should be the CPU, the memory, resource, storage, ephemeral storage, and some of the limits. So we are now coming to a model that, okay, we wanted multi-tenancy. We are having 1000 clusters. So let's try this model and do a namespace per tenant, and maybe that solves our multi-tenancy thing. But does it solve? So some of the things that it does is that there are a lot of tools that are namespace based within a lot of resources, like Kubernetes resources, which are namespace based, and it provides isolation controls. So it provides naming conflicts, so you can have the same pods in the different namespaces. But are they enough? So some of the things that namespace, where the namespace model doesn't actually fit, and it's not practical when it comes to the multi-tenancy thing, and when we want to give full control to a particular person. So how do you generate the configs? How do you do all these things in an autonomous way? What about custom resources? Because custom resources are cluster-wide resources. How do you manage that, and how do you share that across the namespaces? What about the upgrades? Let's say one team wants to work on Kubernetes cluster 1.31, one team wants to work on Kubernetes cluster 1.30. Namespace won't allow you that. It's on the same cluster. And then controllers. Let's say you want to test a particular version of a particular piece of software, Argo CD or Prometheus, in one namespace. Can you do that in another namespace as well? Very difficult to do. So all these things, and also for 1-2 tenants, maybe it's fine. Maybe you can do all of the things on your own. You can manage all of the complexities on your own. But as the number of tenants rises, because we were talking about 1000 clusters, so can we create, let's say 10 tenants, 20 tenants with the namespace level concept? It becomes very difficult, and then it becomes very difficult to manage them as well. This is where there is an interesting project called vCluster, and what that lets you do is it lets you create a virtual cluster. So now think of it as you are creating a virtual machine from a cloud. So you think that that virtual machine is yours, but in the end it is actually running on a bare metal instance. There's just a hypervisor layer on that, and that gives you the instance, and you log into it and you can do whatever you want to do. Can there be a way that we can have a slice, just like we have a slice of the bare metal instance? Can we have a slice of the Kubernetes cluster that I can give it to my team, and they can do whatever they want to do in that Kubernetes cluster, and they are not able to access the host cluster, they are not able to do anything from the host cluster, and if we want, we can share some of the resources which are already there on the host cluster. So that's what vCluster lets you do. So on the left hand side, you can see the previous model where you have multiple clusters, strongest isolation, but you need to install all of the components in a duplicate manner. Now here what happens is you can create a virtual cluster. Now virtual cluster comes with its own control plane, with its own controller manager, with its own optional scheduler, with its own all the stuff, the control plane components that are there, that runs as a stateful set, which I'll show you as well. What happens here is now these resources which are there, Argo CD, Vault, Nginx controller, cert manager, they can be reused for each of the virtual cluster. And let's say I give this particular cluster to a person sitting in the first row and this particular cluster the person sitting in the second row, first they both won't be able to know anything apart from their cluster. They will be given a kubeconfig file. When they do kubectl get nodes, they will be able to see the node on which this particular cluster is running. When they do kubectl get pods, they won't be able to see anything, and it will act for them. It will be a proper Kubernetes cluster, a CNCF certified Kubernetes distribution where they can deploy their applications. And but yeah, for the host, you can see whatever is there as on the host cluster. So, multi-tenancy, instead of namespace, instead of cluster per tenant or namespace per tenant, what makes most sense with this particular piece of software is control plane per tenant. That in the end, what you need is a control plane. So, you just need a control plane, a separate control plane for a separate team, which they can interact with. They can have full access to their cluster. Now think back the analogy of apartments and the house. So, your cluster are the houses and your apartments are the virtual clusters. You still have full access of your apartment, and if you kind of see this, so you still have full access of the cluster, full access of the apartment. You can install whatever you want to do, just like you decorate your apartment, and you are able to reuse some of the resources from the host cluster, from the society. You are able to reuse the garden facility or the lift or the elevators. Here you are able to reuse the Nginx controller, Argo CD and stuff like that. So, that is where definitely, since there it was saving costs, here it is saving cost. There it was saving complexity and maintenance, here it is saving complexity and maintenance. Easy to use and saving a lot of costing as well. So, this is where vCluster sits in. It's an open source project that you can try out, separate cluster, vCluster, and for each namespace. So, this is where vCluster kind of sits in. Yeah, that's simple. What they bring in, I have already explained in an autonomous way. It's a CNCF certified distribution, can deploy as fast as containers because every vCluster will be spinning up as a pod on the host cluster, which will be a stateful set. And this is how it looks like. So, every vCluster is having, so when you do as a user, so this is a user who has access to the vCluster. Every vCluster has a control plane. So, you will be talking not to the host cluster API. So, people usually get confused that when you have so many vClusters, there will be a load on the API server. That's not the case because you are not even talking to the API server of the control plane. You are talking to the API server control plane of the virtual cluster, and it has its own data store, and that data store can be, by default it's embedded SQLite, but it can be embedded etcd. It can also be an external Postgres, and that's what matters. So, all the stuff which is there are the state of the virtual cluster is maintained in its own data store. All the communication happens to its own control plane, and there is a syncer pod, but all the resources that gets created is, or the scheduler that it uses is of the host cluster. You can also optionally have the scheduler of the its own scheduler, that if you just want to do it on a particular like pieces of nodes and stuff like that. And syncer is the place that makes sure the pods that are created in the virtual cluster, how they appear on the host cluster with the naming convention and all that stuff, that's the responsibility of the syncer. Now, coming to Falco. So, what I want to just showcase is, so this is how you can achieve multi-tenancy. Now, how we can secure multi-tenancy, how we can secure those virtual clusters, the runtime Kubernetes using Falco. So, Falco is a cloud native runtime project. These stats are kind of pretty old because I have been using the same diagram. So, stats are pretty new now. So, there will be, pretty fancy stats over there, you can see. There are two types of things when it comes to the security landscape. One is the prevention, one is the detection. Falco sits at the runtime detection of security level, and it was created by sysdig, but it's now CNCF project, and there are multiple contributors from multiple teams. That's what a foundation does. So, what happens in a foundation is that it gets the backing of, it becomes vendor neutral. How it becomes vendor neutral? That's why, because there are a lot of contributors from different organizations that contributes to it. The maintainers are from different organizations. So, it's not run as a single vendor project. There are a lot of vendors that backs it up. What it does, so when your application runs, your application is making a call. That call goes to the kernel. That call is a syscall, and Falco can track those syscalls. Falco tracks those syscalls how? By using eBPF technology. So it uses the eBPF technology, tracks those syscalls, parse those syscalls, enriches them with the data, and then it will be able to alert based on certain rules. So that's how it works. So you have an application that is deployed on a Kubernetes cluster, which is obviously running on Flatcar or whatever that is, or maybe Ubuntu. Hope so not. And then it will be able to, it does the syscall to the kernel, and the eBPF. So there are three modules. There are these modules with a few drivers: kernel module, eBPF probe, and user space instrumentation. eBPF probe, I think, is the default one, but you can use ring buffer as well. So it tracks using the eBPF probe all the syscalls, and then it goes to the Falco engine that sits in the user space. Now here you have the engine where you have all these enrichment stuff. So here it enriches the data and it checks against the rules. So there are a lot of configuration rules which are already present. So Ram mentioned something called using sane defaults. So these are some of the sane defaults provided by Falco, that these are the certain set of rules that we think are important. So what Falco engine does is it actually checks against those rules, against Kubernetes events, audit logs. It can also check against some of the cloud provider things because it has cloud provider integrations. So after checking those, it will be able to give you a result, and that output also can be gRPC, Prometheus, and you can also plug it into a thing called Falco Sidekick that you can then get alerting on Slack or send it to some of the other sources. So that's how Falco kind of works. And this is how, so like Ram said, my demo also was working when I came here. So right now, if it will work or not, I don't know. And that's the screenshot, okay? So it worked, and there was this non-trusted program and sensitive file warning that I tried to open, and it gave me the warning for that, and that's what we need. So that's what we'll try to do in the demo. So we'll be having a Kubernetes host cluster. So we'll be having a Kubernetes cluster, and then we'll be having Falco installed on that Kubernetes cluster. So this is the host cluster right now. So this is the normal Kubernetes cluster that you go to the cloud and you create, any managed cloud provider or even your own Kubernetes cluster. And then you install Falco. Falco will be installed as a daemon set, which will be running on all the nodes. That's what a daemon set means. And then we'll create a virtual cluster, and we'll try to kind of run a SSH server on the virtual cluster and access a particular file. So your Falco should be able to detect that I'm trying to access a sensitive file from that particular pod, and it should give me a warning. So yeah, let's try to do that. So kubectl get nodes. My cluster is up and running, hopefully for a lot of days now, and I already have a few vClusters running. So what for creating and checking all the stuff via vCluster, you can just go to the GitHub, download the CLI, and then you can start using the command. So that's the vCluster list. So I have a couple of vClusters, more than that actually. And also let me see in which context I'm in. Yeah, typing with single hand is difficult. So I am in the main admin context. So like I said, with each vCluster, you will get your own Kubernetes context that you can then switch to. So right now, if you see, if I do a kubectl get pods -a, I should be able to see all the pods that are running on the Kubernetes cluster. So this is something which is basic. Everyone knows it. This is a Kubernetes cluster. We run several pods on it, and in this there is one which is um, Falco. So you have Falco already up and running, and the daemon set is running on that. So now what we'll do is, yeah, this is the gist that you can follow. So you can install vCluster, you can install Falco, and now what we'll do is we'll create a namespace and we'll create a virtual cluster. So let's try to do that. Kubectl create. I mean, even if you don't create the namespace, it will create automatically. CNCG. So that's the namespace that got created on the host cluster. Right now, till now, nothing fancy. Oh, now something fancy happened, right? And now we do a vCluster create, maybe CNCG, in the namespace CNCG. I have to use a different version as well. So now it has started to create the virtual cluster. You can create using all the IAC tool, Terraform and Crossplane, or it has a cluster API provider as well. Install via Helm. In the end, actually it is running a Helm install command that you can see. So you can do whatever tool you like, 100 ways to kind of deploy these. And it is waiting for the cluster to come up. What is happening on the host cluster? So kubectl get pods. So on the host cluster, there should be something that should be happening, which is this. So on the host cluster, it has started to run a stateful set. In this stateful set, there are things that were explained here. So you have your control plane and the control plane components that are part of that particular stateful set. Suddenly what happens is, I cannot see anything. I just see a core DNS pod. So now I am inside the virtual cluster. So that's what I was talking about. This virtual cluster, if I give it to you, you will only be able to see this pod, nothing else, nothing on the host cluster. I am able to run kubectl run nginx image nginx. Name is fine. So it has created a pod. So I can create a pod. I can do whatever I want to do. This is my Kubernetes cluster. This won't affect any of the cluster. Till here, now the one fancy thing that we have done is we have created a virtual cluster inside the host cluster. So it's a Kubernetes in Kubernetes kind of scenario. Now what we'll do is we'll add a secure code box. Secure code box is a give you the dummy SSH service. So I already have the Helm repo added and stuff. So I'll just do the install of that. And in the meanwhile, you can also see that's what it does. And yeah, with virtual clusters, you can have different versions of Kubernetes virtual clusters running on the same host cluster. So you can have a Kubernetes 1.30, Kubernetes 1.31 virtual clusters running. Each virtual clusters can be upgraded independently. Let's say you want to test a fancy feature from Kubernetes 1.31 and you want to upgrade and you don't want to affect anyone out there, you can do that. So it has its own upgrade life cycle. It has its own whatever you want to create with the version specific thing. So hopefully, yeah, it is deployed. So when we do kubectl get pods, we have the server running, the dummy SSH server. We'll try to exec into that. and try to type faster as well. So we should be able to now SSH, not SSH. So with the server that was created, there is a service also that's get created with the dummy server. So I'm just port forwarding into that, and I'm trying to SSH into that particular server, and hopefully the password that I mentioned was able to done. Yeah. So I am into that server. I SSH into that. I now try to uh, read the sensitive file, and hopefully it should, the Falco should pick up these are the Falco rules. So the syscall that happens, the Falco should be able to pick that syscall and put that as part of the logs, because right now everything is going to std out and there is no sync in place, like it's not going out to any Slack or something. So we should be able to see that in the logs. So what we'll do is kubectl config get context. For that, what we have to do is, because in vCluster I cannot access Falco. Falco is on the host cluster. So we have to switch back the context to the host cluster. So we'll just do this and hopefully should work. kubectl config use context. What it does, the syncer pod. So you can see that it should be some few minutes ago somewhere. Yeah, these ones. So it syncs the pods. So I created an Nginx pod. I can see that on the host cluster, but with an additional name attached to it. That's how the syncer attaches it and it adds over there. You can also see the dummy SSH pod over there. And the stateful set and the core DNS are part of the virtual cluster itself. Those are the virtual cluster components. So these are running. What we'll do is we'll just try to see which particular node this is running on, so that we can just check the logs of Falco running on that node. kubectl get pods hyphen and CNCG hyphen ovide. So this is running on pool WT 0HU. What we'll do is kubectl get pods hyphen and Falco hyphen ovide, and we'll just check the logs of HU, this one. kubectl logs hyphen F hyphen N Falco. This is running everything on the host cluster. Grep. There are too many. Yeah, so you can see a warning appearing over here that there was a sensitive file /etc/shadow that was trying to be opened by a non-trusted user. So like this, you should be able to, and here you can see the Falco was installed on the host cluster. I don't have to install Falco for each particular virtual cluster. Every virtual cluster is kind of covered, because in the end, the virtual clusters are running as part of the host cluster. I mean, it's a stateful set that runs over there. So yeah, that's pretty much it that I had in store for today, and you can connect with me. Yeah, you can connect with me, and if you want to learn more about this, or if you want to learn more about build safe, you can also connect with me, or just watch all the stuff on Kubesimplify. Even all the stuff that Ram mentioned. I also did a stream with Ram on supply chain security, protobomb. In build safe, actually we use protobomb, so you'll be able to see the implementation as well. Yeah, go check out, and I hope you learn. Yeah, please. Yeah. Mm-hmm. No, that was the reason I told. So every virtual cluster comes with its own control plane. So when you do a kubectl run nginx, the request doesn't go to the host cluster control plane. So it's not at all overloaded. The request doesn't even go over there. The request first goes to the control plane of the virtual cluster. And virtual cluster is just like any other pod. So if you run any pod on Kubernetes, it will just be managed like any other pod on Kubernetes. Sorry, Amazon? EC2. No, no, no. That's a different. That was just an analogy, just an example. That's a virtual machine thing. This is only for the Kubernetes clusters. So this is if you have Amazon EKS, you can create virtual clusters within that EKS clusters. So EC2 is a separate thing, which is just a virtual machine that you can create on Amazon. Yeah.
Every vCluster is basically a stateful thing.
Yes.
It can't be a pod. I thought it was even somebody mentioned it's a pod, and I got confused because you can't scale vertically pod to a very fast.
Yeah.
Anyways, what about IPs? Because you can like one of the limitations I could think of, but I'm not sure, is that you can't. Still, the number of IPs
Yes.
stay the same in the cluster, right?
Yes. So the default cluster limits would also apply to this because in the end it is running as a pod. So whatever the limits are, and if you want to scale, I mean, yeah, there are, I think there's a 110 pod limit per node, which is there. But yeah, people go beyond that depending on the use cases, depending on like Cilium lets you go even beyond that because of its own capabilities and stuff. So you can use those mechanisms to do that. But yeah, whatever the host cluster default limits, that will apply to those as well.
That will apply to all the virtual.
Yes. Yeah.
You can create different API servers, of course, but at the end of the day, IP so will be
Yes.
allocated from the
Right.
host cluster.
Right.
You can't change the CIDR.
Yeah, you can change that. So there is a file called values.yaml, or basically the vCluster configuration file. In that, you can mention everything. Like you can mention node selectors. Like if you want to target a virtual cluster on a GPU node, you can do that. Or if you want its own scheduler to first, place it, so you can add the scheduler. If you want not, you do not want an embedded etcd or embedded SQLite, which is there, and you want the data store to be live somewhere else, you can have an external data store like Amazon RDS or even on DigitalOcean as a Postgres, external Postgres, and connect that. So that will act as the data store for that particular virtual cluster for the state. What that helps with is the backup and the restore of the virtual clusters individually. So you can scale that, you can have a HA control plane. Those are some of the pro features because this is the open source, and then there is a pro. Pro comes with these enterprise kind of features. There is also one feature called sleep mode. So if you enable the sleep mode for the virtual cluster, if it's idle and there is no ingress traffic coming from that virtual cluster, it will make them sleep. And in conjunction with tools like Carpenter or Cluster Autoscaler, what will eventually happen is it will downscale and it will save a lot of further costing. So for your dev and test and pre-prod environments, this is very helpful.
So regarding the sleeping of virtual cluster, if I don't receive a request for half an hour, the cluster goes to sleep. And if a cluster request comes in,
yeah, it will start. Yes. Yeah, that's why I'm saying it's for developer test and the pre-prod environments, not for the production environments. Yeah.
One last thing regarding, you said we can try different Kubernetes version. So
yes.
Sounds good, but I can see that there could be some limitations. Right? If something very majorly changes.
This is a CNCF certified distribution that comes up with for each virtual cluster. Because it has its own control plane, you will be creating those, the pods which will be running, and that will be only running on the host cluster. That's the only thing. And that's if unless and until there is a very CRI specific thing or CNI specific thing that you are doing. But in general, Kubernetes feature wise, it should not be a problem. Yes. Well, I don't know how much time we have, so yeah. Yes. Sorry, I didn't get the second part. Hardware in the sense? Yeah, it will be able to. So the control plane doesn't interact with the host cluster. Only the syncer pod from your virtual cluster interact with the API server. The control plane will not interact with the host cluster. Yeah, for syncing the resources. Yes, host cluster. Yes, that's why when we created Nginx pod within the virtual cluster, we created SSH server. You would see the mapping of that on the host cluster, because in the end it is running on the host cluster. Like there is no way it can run somewhere in the air, right? It has to run somewhere. So the physical infrastructure or the Kubernetes cluster, wherever it is, bare metal or wherever, that will be running in the same host cluster. Yeah, you can apply all the policies, admission control, Keverno, everything can be applied. Sorry. Yeah, host again, like I mentioned, host cluster limitations would be respected by the virtual clusters. Yeah. No, no, it just the, yeah, that's what core DNS pod over there will be able to kind of do. Yeah, you can do that, but it's they are isolated. So you can use softwares like Cube Slice and stuff to kind of do that.
One last thing, also, I'm guessing it will be, you said syncer is the one responsible to
Yep.
sync resources.
Yes.
So I'm guessing there will be RBAC rules and all
Yes.
only for allowing syncer to.
Yes. Exactly.
But what if I have a use case for, I want some other pod which I think is very smart and should be allowed access to the host cluster. Is there some kind of a scenario for that to for us to achieve that, or
No.
is it a very hardwired rule ki syncer hi karega?
Yes. Only Syncer will be able to do that, and as part of your, like, that's why it is more hardened than your namespace as a tenant. But obviously, if you create separate clusters, that's a altogether very different story.
My pods inside that vCluster would not be at all aware of any.
No, not even what is running on a second V cluster, not what is running on the host cluster. And everything can be applied, like Coverno policies or whatever that is, those can be applied across as well. And also you can have all these as part of your CI pipelines. If you want to do a fleet update to the clusters, you can add that to the Argo CD. You can use the same Argo CD instance, add those virtual clusters, and do a fleet of updates, however you want to take that. You can also use, for example, the same cert manager and the same Nginx ingress controller, because the ingress classes will be synced over there. The secrets are synced, because when you create a certificate, the certificate gets created on the host cluster. The host, when the certificate gets created, there is a secret that it automatically creates. So those secrets are again synced back, so that vCluster is aware that this is how it has to be mapped for a service for an ingress, so that when you hit, it actually works. And you don't have to install separate Nginx controller for every vCluster.
Just confirming, like, hypothetically, I want to try a CNI. I can't try it inside a vCluster.
I think you can change, but I'm not sure. I also need to check that.
How would it be possible to try?
Yeah, I also don't think, but I think there are some things, some workarounds that you can do, but I need to check that. Yeah, awesome. Yes.
Do you do pairing between the clusters? Like if you want to separate staging and their environment.
Yeah, those can be simple, just as you give labels. So you will be able to give labels to your virtual clusters as well. So there is a vcluster.yaml file where you should be able to specify all the things.
Or we can pair two clusters.
Pair in the sense,
Pair in the sense like VPC pairing.
No, each cluster is isolated. So every cluster is, if you want to like do do a HA kind of scenario where you want a pod to be scheduled on this virtual cluster and this virtual cluster, that will be a very tricky scenario and can be done maybe using cube slice. I haven't tried that, but it's mainly that you have a HA. You can have a HA in the pro feature. You also have can have a HA control plane for your virtual cluster, and then you can have it spanned across different nodes, and that can act as your HA rather than pairing of the virtual clusters itself. Yeah, we don't want them to access, right? We want them, because as teams, as separate teams, 1,000 teams, I want separate virtual clusters for everyone, and that will lead me to managing less Kubernetes clusters in the end and giving out more virtual clusters to the team. And it very well fits in the scenario of, you might have heard of platform engineering and building internal developer platforms. So vCluster can sit very well in that, and within that API call, it can create as a developer request for a Kubernetes cluster. So it goes to the IDP platform, uses vCluster, creates a virtual cluster, returns back a kubeconfig file, and it gives that to the developer, and they are happy with the Kubernetes clusters. Without multi-tenancy, what it will be, there is the same IDP platform, but instead of creating a virtual cluster, it is actually creating a Kubernetes cluster. In the end, developer is still getting the same thing, but it's more cost to the company and it's more clusters to be managed by the company. Okay, I'll be here till 3 p.m. and if any questions, please feel free to ask them during breaks. I hope there are breaks.
Yes, yes.
Okay, yeah. Thank you.